Okay, so in this question, question 2, we have two objects A and B. A has a mass of 8 kilograms and B 4 kilograms respectively, and they're in contact with each other, so there's nothing in between. They lie on a plane with an incline of 30 degrees to the horizontal, and a force of F is applied to the incline, and it pushes up on the objects as shown in the diagram. Okay, so here we go. State Newton's law of motion second law of motion in words. Okay, Newton's second law, the first law is when an object is in motion, or if it is stationary, it will stay in motion, or it will stay stationary unless a net force is acting on it. And so point being is that if there's no net force, there will be no acceleration. That's basically Newton's first law. Newton's second law is now talking about when something is accelerating, then the acceleration would be equal to the change, or it will be directly proportionate to the net force and inversely proportionate to the mass. So let's see what the student said. The net force acting on an object is equal to the rate of change in the momentum of the object in the direction of its momentum. Now this is Newton's second law in terms of momentum, so I'm not sure if they will give this to you in a final exam. If we were talking about momentum and they asked for Newton's second law in terms of momentum, then this would have been the net force acting on an object is equal to the rate of change in momentum. But I think it's acceptable to have this. Okay, but more accurately is that the acceleration experienced on an object is directly proportionate to the acceleration and indirectly proportionate to the mass. Okay, the magnitude of the kinetic friction acting on object A is 6.8 newtons and on object B is 3.4 newtons. So A is experiencing 6.8 newton friction and B 3.4. Draw a free labeled body diagram of all the forces acting on B as it moves up the incline. Okay, so let's quickly look at this graph. This is a perfect graph. Okay, first of all, we have gravity, the force of gravity, which is directly downwards. Then we have the normal force, which is directly 90 degrees to the plane. Okay, so the plane is at a 30 degree angle, and the normal force is then 90 degrees to that. Then in the direction of the plane, we have a force exerted. Now the force that's exerted, I don't think I would have given the mark here, but the force is exerted by A. So A is pushing on B. Now it is indirectly F that's pushing on A, but A is in turn pushing on B. So I would have just indicated here that it's the force from A. And then here I can't see, this is an Afrikaans student, so he's obviously using W for wrijving, that's friction. Okay, it looks like a W for me there, I can zoom in, but yes, this would be the frictional force that is always directly in the opposite direction as motion, and since it's going up the incline. So beautiful 4 points there for you, student 1. Let's look at the next answer. Calculate the magnitude of F if the system moves up the incline at a constant velocity. Okay, so this is what this student did. He started with this formula that the net force is equal to mass times acceleration. Very good. And then he worked out the net force, and I'm going to try and figure out what he did here. We can maybe try zooming in a little bit. Okay, maybe a little bit more. Okay, there we go. And let's see. So what he said is that the net force, and now let's just see what are all the forces acting. Calculate the magnitude of F. Okay, so on F is a force that's acting on A, and so we need to consider all of the forces that's acting on A. So on A we have income and expense forces. Okay, so that's what adds up to the net force. First of all, the income force is what's helping this thing move up the incline, and that is the force of F applied. The expense forces is his weight, which is moving downwards. Okay, so we have mass times gravity times height. That's good. That must be an expense, so it's going to have a negative. And then there's a force that is, I don't know what the FA, oh, that's friction of A. And then he's also including the friction of B. Let's just see. He seems to be treating this whole thing as a unit. I think that can work. This could have just been one single unit, but then the friction of this one, I don't know if you can just add it together. I think you might. I don't know what the correct answer is. Let's just see here. Okay, so he's adding these two frictions together. This one's friction, that one's friction, because both of them are forces in the same direction. So I think you can add them together. In mass times gravity times height, you just said 12 times sine 30. And then he just solved it. What? That is 6.8 minus 3.4. I'm not sure if the subtraction there is what he really did. Let's just see. Let's just see the 6.8. That's the friction experienced by A plus the 3.4. This will be their combined frictional force. Both of them are experiencing that amount of friction. They're vectors in the same direction, so we can add them together. That's fine. Gives me 10.4. Okay, so far F has to work against the 10.4. And so now next is our weight. Oh, should have done that. Next is the weight. And the weight is going to be, okay, so we want that length there. That would be weight, is it? Okay, my weight is downwards like this. Actually, I've been doing this wrong. This H is not, this NGH is not the weight. The weight is just mg. So that part is wrong, but he seems to be doing this still correct. It's just mg sine. I just want to work out here on a sketch if that is true. Guys, I really don't ever remember the formulas. I suppose I should. It would just go quicker. But if that's my object, then this is my weight. This is my downwards motion. The weight's parallel to the surface, and that's the one I want. And then this one is theta. This is my total weight, and this is the weight that's parallel. And so that is on this. Okay, perfect. So it is sine theta. Excellent. So that's 30 degrees. So that is 12 times 9.8 times 30 sine. Okay, which gives me 58.88 plus the 10.2. Okay, you see these two are in the same direction. Weight is down the slope, friction is down the slope, so they had to be in the same direction. So I do think this is his error here. Instead of having, he should have subtracted the 6.8 as well. Okay, so the fact that he is, the 6.8 is negative. Yeah, he didn't add these. I know somehow he's making a mistake to lose 12 newtons. So 69 newtons seems to be the correct answer in the end. 69 newtons, let's just work that out again. It is 6.8 plus 3.4. I'm now adding all of the forces that's down the slope, plus that, plus 12 times 9.8 times 30 sine. Yeah, 69 newtons. That seems to be the correct answer. Now, let me just show you how I would have done it, because I must admit I didn't initially thought of just using it as a single, as as a single thing. So I would have done it like this. I would have said, okay, I've got my box B, and A is exerting a force on box B to move it up the slope. Okay, and so here's A. So I would have had, this is the force of A on B, and I'd work out what must that force be. So this thing is experiencing, so force A is just equal to the sum of all the forces. So force A is, this thing is moving upwards, must just be equal to the weight down the slope and the friction down the slope. So we've got two forces that's downwards, that's stealing from his motion. That's the weight parallel to the surface. Sorry, my pen is not working well today. Parallel down the surface, and we've got the friction. And so we would have just worked that out. So the friction is what force? The friction was 3.4, the 3,4, and the weight down the surface is 12, it's not 12, it's 4. I can't remember the units. I think it was the 4 kilograms. Okay, it is 4 kilograms and 3.4. So 4 times 9,8 times sine of 30, which you did beautifully. Okay, and then we simply for the force of F, there's then a force being applied to F, and this F is then equal, the force applied, since this thing is going at a constant velocity, it means that the force applied is equal to all the forces that's downward. And so if FA is pushing on B, B is pushing on FA. That's Newton's third law, is pushing on with the same side. So the force applied to A, let's use a small a, the force applied to A is then equal to all the forces that's downward. Now B is causing a force downwards, and then the weight parallel to the surface again here, as well as his 6.8 newtons of friction. So his friction as well as his weight, which is 8 times 9,8 times sine of, and I'm just not sticking to my size, sine of 30. Okay, and FB then, and I see it should get to the same answer, because we're still adding the same things than we did in his answer, so it should also come to 69 newtons. So his method was also perfectly fine. Usually if we're pulling on something, it's this force in between that I think would be the snag, and more difficult to calculate. So this was actually very, very simple. Next question, calculate the coefficient of kinetic friction for B. And so here we had, okay, here's the formula, 3,4, here's the formula, the force of kinetic friction is equal to the coefficient of kinetic friction times the normal force. The normal force is just this formula, your mass times gravity times cos of 30. So your normal force just uses the opposite trigonometric ratio than the weight. So this is perfect. But then here he's got a little plus. I don't know why he's got a little plus there. He shouldn't have the plus. So I don't know what his calculation comes down to. It's multiply. So in other words, you'll have your 3,4, and since you're multiplying the kinetic coefficient, you just divide with these numbers. So we divide with 4, we divide with 9.8, and we divide with 30 cos. So all of those things just gets divided, and 0.10. So he definitely got it correct. He just accidentally put in a plus there. So well done. There's also no units for it. Okay, we don't put any units for the coefficient. So well done. You're doing really well, student 1. Student 1. The angle between the incline and the horizontal changes to 35 degrees. How will the answer in question 2.3.2 be affected? Write down increase, decrease, remain, or the same. In other words, will the coefficient of kinetic friction change? Okay, well, it remains the same. No, that is a constant for any surface and object on the surface. So box A has a unique coefficient of kinetic friction, and the only thing it depends on is the surfaces, the actual surface. So no, it won't change no matter how you change the incline. Now it will affect the kinetic frictional force. Okay, so for example, this number doesn't change, this value, but the normal force changes. So if cos 35 increases the angle here, so let's just quickly work it out. Cos of 35, 30 cos is 0.86, 35 cos is 0.81, so it decreased. So cos decreased, and as a result, this whole expression will increase. How will this affect the magnitude of the friction? Right, increase, decrease, or remain the same? It is obviously decreasing. Okay, so you'll say it decreases because what changed? The normal force decreased. It decreased because the normal force decreased, causing the frictional force to decrease as well. So strange, it's 3 points. I would have given it 2 points. I don't know if there's something else they want there, but my answer would just be it decreased because the larger angle decreases the normal force experienced by the box. I don't know. Hopefully there was something extra to give a mark for in that sentence. Excellent. That was question 2, the Newton law question.